Hello, Arc Junkies, and welcome to another bonus episode of the Arc Junkies podcast. While I was at FabTech this year, I had the opportunity to catch up with the team over at the ESAB booth to chat about some of their new innovations, machines, and technologies that will make your life as a welder or a business owner that much easier. In this episode, we discuss the heavy industrial side of ESAB and take a deep dive into the Warrior line of machines. We chat about carbon arc gouging on CV, which I've never heard of before, and we also discuss the new cloud-based system ESAB has to keep you up to date in the shop. We also talk about the light industrial side of the product line, including the all-new ESAB Volt battery-powered welder and the new water cooler option for the Rebel line. Then we shift gears from manual welding and jump right into automation using cobot applications and sub-arc systems. And then we wrap up the episode with some digital solutions, which if you're a welding data nerd like I am, you're going to love the new technology. Let's go ahead and get into the episode.
You're listening to the Arc Junkies podcast, helping you make every weld better than your last with each episode. And now your host, Jason Becker.
I'm over here in the ESAB booth, FabTech 2023 in Chicago. I'm here with Jeff Chittum. Jeff, you are with the heavy industrial product line of ESAB. What do you guys have new coming out for FabTech?
So, new for ESAB HIP in North America, we have what we call the Warrior Edge. It's a 500 amps, 60% duty cycle machine, 380 to 600 volt input power. So it's our advanced process machine. It's got mild steel, stainless steel right now. We got aluminum coming at the end of the year for synergic mode, manual, MIG. We have pulse. It can do stick, TIG, MIG, gouging. So it's a multi-process machine.
Machine, CCCV.
Yeah.
Okay.
But it also has the pulse waveforms. And we actually have a new pulse waveform called Speed. So it's a high deposition MIG process for mild steel and stainless at the moment. So it basically, with Speed, we are monitoring what's going on in the arc. So that's kind of what's new with the Warrior Edge machine is we can see what's going on in the arc. We're monitoring what's going on in the arc. So any changes in stick out, you get into the corner joint, so that joint moves away from you a little bit. We control the arc. So if you're looking for an exact arc length and arc bead or a bead characteristics, we can monitor, adjust on the fly so that any changes in stick out.
So kind of like a synergic mode, the machine's doing it all for you?
Yeah, we're doing it for you.
Kind of making up for poor technique.
Yeah, we're not changing wire feed speeds or anything like that, but we can modify the amps and volts a little bit as you're welding to stabilize that arc, maintain the bead profile that you're looking for, reducing spatter, that sort of stuff. So anybody grabbing that MIG gun, whether it's a new welder or somebody that's been doing it for 30 years, right, just to get that repeatability out of it.
Okay. And then what sectors of the industry do you see this being primarily used in?
Like I said, it is a heavy industrial product, right? So 300 amps or 500 amp, 60% duty cycle. We're looking at some of the oil and gas, structural steel guys. Some of the big agricultural manufacturers are looking into this type of machine. So it really is kind of that production environment.
Okay. So what's one thing that kind of separates ESAB away from some of the other OEMs with this technology?
What really sets ESAB apart is, one, we're monitoring what's going on in the arc. So we've paid a lot of attention to the arc characteristics. We want sophisticated, advanced processes. But what we also want is simplicity of setup. So we understand industry's changing. We need to keep up with industry. We need these advanced processes. But what we also don't want is to complicate things. So we really paid a lot of attention on let's make it as advanced as we can, but let's make it as simple as we can for new operators. So guys out of school, they walk up, they want to learn how to program it right away. We have an internal screen inside the feeder. So they set it up quickly. Then 2 minutes, everything is ready to go. They shut the door on the feeder.
Oh, it's on the inside of the machine.
Yeah. So there's an internal screen. So if you look at our product, it's the Robust Feed Edge. And so you flip the door up where the wire goes and where the drive stand is. And so inside the screen, you tell us what wire you're using, what gas you're using, what wire diameter. And then you shut the door, and then you select your process from the outside. You got your wire feed speed, your voltage, programs 1, 2, and 3. So you do the programming on the inside, shut it, and then you do your day-to-day welding.
You can do your fine-tune adjustments on the outside.
Exactly.
Okay, that's very slick. I've never seen the interface be on the inside of the machine before.
Yeah, so
I think that's, not to cut you off, but that's something cool that you guys do that none of the other OEMs do is you've got little features on the inside of the doors of your products, whether it's contact tip holders, extra place to put the drive rolls, a light, because we all know lighting in shop is just poor.
Right.
So you open it up, and, I mean, everything's well lit. You know, you got easy access to everything.
Yeah, and so all of our drive rolls are color coordinated per the diameter that you're using. Like you mentioned, the storage. So there's contact tip storage in there, your drive rolls, all your inlet, outlet guides are all there. So everything's nice and organized. The LED light, we also have a heater inside of our feeders. So if you got guys running flux core wires, H4, H8s, you turn on the heater, and then when you're done your shift, you don't have to take the spool of wire out of the feeder, put it inside another container to keep it in H4 overnight or over the weekend. So you turn the heater on. It's around 40 degrees Celsius, 110 Fahrenheit. Just keeps the dew point out of that feeder.
It keeps all the moisture off.
Exactly. Yeah. So your H4 wire that you're paying all that money to be an H4 wire, it maintains that. And so you have, when you come back on Monday morning after the weekend, you know that you have that solid wire that you need again.
Oh, that's very slick. And I like the fact that the user interface is on the inside of the machine, too, because that keeps all the sparks and spatter. You don't have to worry about new lens plates and all that stuff.
Exactly.
Or bumping into it and, all that good stuff.
And so that's, the welder, he's really looking at the front screen, right? So, again, these are the heavy industrial products, right? So these are in factories and high productivity areas. So you may have a weld engineer or a shop foreman that's, using the inside screen, doing some programming, that setup, that sort of thing. The operator, he's looking at the front screen. He's got his wire feed, speed, voltage, his 3 programs, and he's ready to rock that way too.
So it keeps it super simple for not only the manufacturer, but the welder,
right?
The guy out there in the shop playing the beads.
Yep. Something else that the Warrior Edge comes with, so it comes with Weld Cloud connectivity right from the factory. So if you want data management is really what we're looking at there. So it comes with Weld Cloud Fleet for free for life with the subscription. So with that, you get software updates. You can do all of your weld data sets, so your programming. And so if you purchase one machine, you set it up, you save 25, 30 programs in Weld Cloud, and then you get the rest of your fleet. You're literally from your office, you can send out all of those weld procedures out to every machine. So every machine's instantly all set up. They're all the same.
So you got them on an internal network, or they operate through Wi-Fi?
So this would be you can do it either way. You can do it through Wi-Fi and through the cloud-based Microsoft system, or some places you can't use the Wi-Fi at their buildings, and so there's an Ethernet port too that you can hardwire it directly to their network.
Okay, and then can you pull up like real-time data, what the machine's actually doing as far as volts, amps, all that good stuff?
Yeah. So as soon as a welder's done doing a bead, you just hit refresh, and then all of his parameters will show up. So you got wire feed speed, deposition rates, arc-on times, voltage, amperages, and then with Warrior Edge, we actually have a digital gas control now. So instead of looking at a flow meter, and you have the ball on top of the ball, bottom of the ball, we set it, if you want 32 cubic feet an hour, you digitally set it 32 cubic feet an hour.
I've never heard of that before. That's insane.
And then it's tracked through Weld Cloud. So you got your gas consumption, you got your gas usage per weld and overall at the station. So we have a lot of end users that are saying, shielding gas, it's a necessity. You need it for welding. But how much are we actually using per weld, per part? They got a ballpark idea, but this is actually getting them their exact usage. So when they're quoting jobs down the road, they know exactly how much gas they're going to use. What's that cost really to them per part?
That's a huge benefit to the end user because, the fact that you can manage all that, have access to that data as far as, like, what is it costing, per linear inch of weld? What is it costing? How much weld are we actually putting in there? The cost savings in that alone, just from an estimating standpoint.
Right, exactly. And so we got on the gas side of things. We also have on the wire side of things. So deposition rates, how many grams or how many pounds are we welding per part. So you have that exact measurement of what really you're using so that you can quote a lot more accurately that way.
Now, what are we looking as far as size and weight of the machine?
So it is a 500 amp machine. Currently, it comes with a water cooler. So the power source itself, it's about, I think, 110 pounds. It is an inverter base. So, and then the wire feeder, without wire in it, obviously, it's about 32 pounds.
Okay.
And then you would put your spool of wire. So solid wires are 30 pounds. So for the most part, the feeder gets mounted right on top of the power source. But there's handles on the feeder, and they're crane certified, so you can put them on a boom system if you want. Hook it up to your crane if you're going up on top of scaffolding, that sort of thing. So those types of advantages are really endless with the portability of those feeders too.
Okay, that's pretty sick. Now you mentioned the water cooler in there. Is that for the MIG welding process, or is that strictly for TIG, or can you do either one?
It would be for either one. So if you got a water cooled MIG gun, then you would be able to hook it up directly that way. And so the Warrior Edge, we launched it in January of this year. So we still have models that are rolling out, some new processes that are going to be being developed. So currently right now, it does have the water cooler built into it. Non-water cooled versions are going to be coming out before the end of this year.
Okay.
So that's kind of what's new for us. The last piece of technology that's new to ESAB, really on the HIP side of things, is what we're calling a current breaker. So you're looking at advanced short arc processes like root and thin welding. So open root for pipe or plate. So that hardware technology, something that we've been missing for a long time. We knew that we needed it to
stay competitive.
Right, exactly. Competition has it. But our legacy platforms, the technology really wasn't able to handle it. And so that was kind of one of the driving factors of developing this new Warrior Edge platform. Was we needed to be capable of all processes, but we really wanted the sophisticated ones. And so root welding, you look at the red and blue competition, they got their own versions of it. And so this is what we're calling our own current breaker, to really have that modified short arc process for root.
Okay. What's the name of the waveform that you're pushing?
So we call it root. So that's
it's just called root.
We call
Plain
it root.
and simple.
So
you
exactly.
Can't mess that up.
That's I talked about it earlier. We wanted this to be very simple and easy to use. So our competition has some funky names for some of their processes and their waveforms, and we called it root. I mean, that's what it's used for. There's another one, thin. I mean, it's thin
just
material,
makes sense.
Right? It's a modified short arc for thin material. The one that we have that's new on the machines right now is called Speed. It's so that you can weld faster. It's a high deposition rate spray transfer with a pulse overlay on it. That pulse overlay is allowing us to monitor what's going on the arc, so we can adjust our amps and volts so that we stabilize that arc for the welder. Like I was mentioning, they change their stick outs or they get into a corner, so that joint moves away a little bit. So we're monitoring things, but it's all about control, stability, arc characteristics. And then we named it Speed because once everything's stabilized, you can travel a little bit faster that way.
Okay, well, like you have like a percentage or like I don't know, like how much faster are we traveling? I mean, it's going to vary based on joint configuration, wire type.
I'm not saying if you're welding at 350 inches a minute, you're going to jump to 900 inches a minute, right? But you may be able to add a little bit more wire feed speed, travel 3-5 inches per minute a little bit faster manually. Once we get the robotic integration, that's when this is really going to take off on the speed side of things, right? Is the robotic increased deposition rates and travel speeds.
That's also going to decrease the amount of heat input. Anytime you can increase your travel speed, you get a lot less heat input into that part. You're taking care of the warping effect.
Yep, exactly. So that's really what we're trying to accomplish with Warrior Edge, is create a very sophisticated, advanced process machine, but very intuitive, easy to use, easy to set up.
That's awesome, and I like the fact that you guys have that weld cloud, so you can actually, once you get new processes, waveforms, updates, anything like that, you can just beam it right to the machine.
Yep, yeah, you can do it two different ways. There's a USB port where you can just upload, or if you're connected to Weld Cloud, I mean, you can literally sit in your office and just start shooting out advanced processes, all new programs that you want to do. If there's software updates, you can create a weld data set, so basically your combination of wire feed speed and voltages, and send it out to the power sources that are out on the shop floor.
Okay, so you can actually develop the procedures in the office, send them out to the shop floor. Now, can you lock that to where the welders can't go in there and say, I like to weld like this?
Yeah, exactly.
So I'm going to switch the dials and everything. You can actually lock it out?
So, yeah, we lock it out. We know that every welder's different. Everybody, some people like a real tight, crisp arc. Some people like a big, wide open, high voltage arc. But with Edge, we wanted to make sure that we kept the stability of everything. So what we do is we set a limit. So say your weld procedure is 30 volts and 500 inches per minute wire feed speed. And you are certified to either the Canadian Welding Bureau or AWS, and they give you, plus or minus 10%, 15%. And so you can put those ranges in your weld data set. So if you're at 30 volts, you can do 28 to 32 volts. And then your welders are able to adjust in that. So you keep the stability of the arc. You have the quality of the arc. You got the penetration that you need for the strength. But welders are able to manipulate things a little bit to the way that they like it.
Okay, that way you make sure everybody's getting the same exact ingredients to make the same weld
exactly.
over and over.
Yep. And so we have wire feed speed and voltage adjustment like that way, so you can have your limits and be able to adjust things. But we also have is arc length, so you can control that. But we also have a new one called dynamics. And so dynamics for ESAB is there's different parameters, especially on the pulse side of things, right? So if you're pulse MIG welding, you have frequencies, hertz, slopes, peak currents, background currents, right? So there's 8 or 9 different variables. And so with Edge, we wanted to keep it simple again. So there's one dial called dynamics, and you literally take all 8 of those and shift it up a graph and down. And so keeps it very simple, easy to use, but you're able to have that. Some people are calling it that happy knob, right? It's allowing people to adjust things, keeping it very simple.
Okay. What do you have any other advanced processes or anything in that machine for some of the other or advanced features, I should say, for some of the other processes that are in the machine outside of gas metal arc?
So on the gouging side of things, ESAB has really taken a stance on gouging on the CV side of things. And so what that does is we actually have a reduction in decibel noise. So we have some end users that are, instead of having double ear protection, they got the plugs and then they got the earmuffs over top. When they gouge on the CV side of things, we had an end user gouging with a 5/8 carbon. They were able to remove the earmuff, so they just went to a single source hearing protection because they had a noise reduction. And so that's one of the things on the CV.
Not to interrupt, when did that technology come about? Is that something new this year, or is this something you guys have had on previous models?
Yeah, it's something we've had on previous models. And it's one of those things where we know the technology is there, we know what it's capable of doing, but if you look at shops, everybody does it differently, right? So it's hard to go to one end user and say, you know what, you're going to have an 8 decibel noise reduction. The next guy might have 10, but then the next guy, depending on his arc lengths and where he sets his voltages for gouging, he might only have 2 or 3. So it's not really something that we could, blast out there and say, you're going to have this exact amount of decibels. But it's definitely something, if you're in a shop, high productivity, and you're doing a lot of gouging, I mean, when you walk into a shop and there's 10 guys gouging at a time, it gets loud real quick. Yeah. And so if gouging is something that your facility is doing quite a bit, then definitely look at ESAB welders, because gouging on that CV, there will be a noticeable difference when you walk in on the shop floor.
That's what my instructor told me when I was coming up learning welding and everything. We introduced us to carbon arc gouging. He said, this is when you know that somebody really messed up on the job, because it's usually meant for cutting out welds, but also for joint preparation. But yeah, usually when somebody's using it, they're cutting out a bad weld.
Yeah,
now,
exactly.
I've never heard of gouging being done on CV. It's always been a constant current process. So with that, how do you set your variables for CV? I'm assuming you're just setting your voltage.
Right. Yep. So I mean, if you look at most of the ways that in the industry has set carbon arc gouging in the past with setting an amperage. So now we have a chart because it is new, and a lot of people aren't fully understand how to set the voltage. So if I have a 1/2 inch carbon, what voltage do I set it at? So we have a chart to help everybody set it up. And but yeah, you set your voltage now instead of setting your amperage for carbon arc gouging.
Yeah, even with the amperage, I'd always refer back to a chart. You get the manufacturer specs and everything, and it tells you for this diameter run this many amps. But yeah, I've never heard of carbon arc gouging on CV mode. I've got to try that.
Yeah, it's and we have it on the Warrior platform too. So our CCCV machines, it does it. The Aristo, the entry level pulse machine, it's also gouging on the CV side of things. So our whole HIP portfolio is doing that.
That's very impressive. That's neat. I had no idea you could run it on constant voltage. Yeah. Well, cool. Do you guys have you got any other products in the HIP?
So HIP, like I mentioned, we have the Warrior, which is the CCCV multi-process machine. There's a 400, 500, and a 750 variation of that machine. The 750, we actually parallel them together sometimes. You get 1,500 amps. Guys gouging with 1-inch carbons.
Yeah.
I mean, not something I want to be doing every day, but we definitely got the capabilities to do it. So that's the Warrior. And then the entry level to pulse is the Aristo, the 500 amp machine, 60% duty cycle. It also has a process that we call super pulse. It's our pulse on pulse, but we call it super pulse instead of pulse on pulse because we can actually do short arc on short arc. We can do spray on short arc. We can do spray on spray. So you can really take that, out of position capabilities. Some people are using it to do fill passes on pipe and things like that. So that's the Aristo, and then you step up to the Warrior Edge, the new platform that we launched this year. Those are the multi-process. Those are all MIG, stick, TIG, and gouging. And then we do have a Renegade machine, which is a 300 amp, runs on single phase or 3-phase, and we have a stick variation, and we have a stick TIG, so it has DC TIG.
Okay. Is it foot pedal or scratch start, lift arc?
So the DC TIG, the Pulse DC TIG will have high frequency start. The stick variation, that will still do DC TIG, but that one will have lift TIG.
Okay. Very cool. Yeah, I had to mess around with the 205 IC the other day. And
Okay.
I kind of had to tell it that I was stick welding and just use a different setup for my my TIG torch. I had to use the one with the valve on there. That way I could actually perform a scratch start.
Right. Yep,
Yeah.
absolutely.
And it worked like a bomb, man. It was awesome.
The 205 is a great little machine.
Yeah. Well, cool. Jeff, I appreciate you taking the time out of your day, out of the show schedule and everything to come on here and chat and get us educated on HIP.
Yeah, no, my pleasure. Thanks for having me.
Yes, sir.
All right, thank you.
All right, joining me now is Mike Sammons with the Light Industrial Products. Mike, tell me a little bit about what you do here at ESAB.
Yeah, so I'm a global product manager for ESAB that covers the light industrial equipment, so that includes stick, multi-process, as well as MIG machines.
Okay. What product category falls under your line?
So I have Rebel family, I have the Rogue MIG family, I have the Renegade Volt, and the Rustler product coming out of Europe.
Okay. Tell me about this Volt system because it seems to be kind of making some waves. It's pretty cool that you got a battery-operated technology for a welding platform.
Yeah, it is. It is absolutely have a big wave. It's been packed around the booth all day long, so it's been good. Renegade Volt is a battery-operated stick TIG welder that runs off of 4 DeWalt FlexVolt batteries. The power supply is a standalone power supply. Then we have a battery box. And it runs on 3 different modes. You can have mains power, so you just plug it into the wall, 115 or 230. And then you can run it off battery only, or you can run it off a what we call amp plus hybrid mode, which you use both the power supply that comes out of the wall as well as the batteries that stack underneath.
Okay. So with each different option of power, what kind of amperage are we getting out of those? So like if it's just battery only, what kind of amperage you pushing?
Up to 150 amps on TIG and 140 amps on stick.
Dang. How long can you to weld with that process?
So we
Battery
do it more by electrodes because obviously that depends how many amps you're going to be drawing. But the 330-second electrode, you can get about 30 electrodes.
Jeez.
Yeah.
Okay, that's pretty impressive.
So we go like 30 for 330 seconds, 20 for 1/8, and 10 for 530 seconds. Kind of easy round numbers.
Okay. And then if I plug it into the wall, what kind of amperage?
200 amps.
200 amps.
If you run on 230.
Okay. Now if you combine that with the batteries, what are you getting out of it?
You can get up to 200 amps as well.
Okay.
Yeah. So the idea behind the Amp Plus mode is that if you're on, it's more for kind of like the 115 category, because you only have 15 amp breakers or 20 amp breakers, so you're only going to get so much out of the machine.
Right.
So when you're on Amp Plus mode, the idea is that we watch the draw on the primary side of the mains current, and then as soon as we start to approach that 15 or 20 amps, then the batteries start to kick in.
Okay.
So you can get more out of a 115 volt line than not.
I got you.
So
Yeah, I mean, I could see a lot of benefits. So like going out to the hunting camp, going out for the weekend, you throw that in the back. What type of weight were we talking about?
So with the batteries in the battery box, you got 25 pounds in the battery box and 26 pounds in the power supply. So roughly 50 pounds.
Well, that's not too bad. That's like about the weight of most portable inverters.
Exactly.
Okay. And then you can just drag it around the job site wherever I mean, that would have been great for, when I was out doing handrail repairs and guardrails and all
absolutely.
that stuff. Just not have to run a generator or look for an extension cord or an outlet.
Exactly.
And then as soon as you plug in the battery or the breaker pops, then you got to go track the breaker down.
Exactly.
Solving problems out here, Mike.
We're trying.
What else do you guys have this year at FabTech?
So the other thing new in the light industrial category is the Rogue MIG. So Rogue EM 190. It's the third edition to the MIG side. So we have a Rogue EM 125, EM 140, and EM 190. So 125, 140 run off a 115 volt line, and the 190 runs off 230 volt only, single phase.
Okay. Awesome. What what processes that you say that covers?
MIG.
MIG.
Yep.
So standard, just regular CV?
Yep, CV. So the Rogue 190 is definitely a step up from the 140, not only from output and performance, but also from a feature set. So it's got a 5-inch TFT display, has 27 different languages in it, and 27 synergic lines or programs, depending upon the terminology.
Okay, so kind of like SMIG?
No, so SMIG is something that is a taught process or a learned process, whereas a synergic line is something that's already been predetermined.
Gotcha.
So we've established the volts and amps for each material thickness the machine's capable of, and then we tie them all together and just single knob control from top to bottom.
Okay, so as I adjust my amperage, the voltage is automatically going to synergically set itself to exactly where it needs to be.
Correct.
Takes a lot of the guesswork out of where I need to get both dials.
Absolutely. And we set it by material thickness, so you don't even really care about volts and amps anymore.
Perfect. So you're looking at what, probably 5/16?
3/8.
3/8?
Yep.
Okay, you can get up to 3. Yeah, because 190. Yeah.
Yeah, definitely if you run some flux where you get up there. So.
Okay, yeah. Do you guys have an 035 flux core wire? Gas shielded flux core?
Yes. Core Shield 15.
Core Shield 15. I got to remember that because I need to get some for the school.
Yeah.
Yeah.
It's good. It's the best running Core Shield cord wire out there, in my opinion. It's just a general purpose. So.
Yeah. Okay. What other options do you have this year? Or you said you had 3 machines?
Yep. So then we've refaced, if you will, the Rebel 205, the AC/DC. So what we've done is we've actually added a water cooler to it now. So it's a new system. So unfortunately the cooler is not backwards compatible to older machines. But moving forward, you just plug the cooler into the back of the power supply, and you got a water cooled TIG system now.
Okay. So is it a separate unit, or is it all internal machine?
It's separate. Yeah.
Okay.
It's an add-on.
Okay.
So you can buy the new Rebel by itself and add it later, or you can buy them together.
Okay. I love the 205 IC. It's a great running machine. That's the one we use over at Underground Metalworks. I can teach my entire comprehensive class on that. Yep. Stick, MIG, TIG, flux core, steel, stainless, aluminum. It doesn't care. Whatever you put in front of it, it's going to weld it.
Agreed. Yep, absolutely.
Now, do you guys have any plans of putting like some of the more advanced processes? I was talking to the Jeff from Heavy Industrial. Do you have any plans to incorporate any of those new modes of metal transfer, like speed or root or anything like that, into the 205 lineup? Or not really necessary for. So,
from the Rogue perspective, no, because that's more of the home hobbyist crash and dent, maintenance repair kind of a scenario. We're still in the evaluation process of what comes next for the Rebel family. When it comes, we will do a rebranding of it, so to speak. So it'll look a little bit different than it does today.
Okay.
You'll know it. So,
out of the machines you have, which one's your favorite?
Oh boy,
that you got to work on.
So Rebel 205 definitely has got to have a soft spot in my heart. But the Rogue MIG is really where I've spent most of my time in the last 12 months. And then they're all good, because then the Volt stands out on its own self. So yeah,
I'm looking forward to trying that one out. Yeah. I think Sam Welds has one. He was playing with it on the Instagram there.
Okay.
Yeah, so he's got one up in his shop, and I was like, man, that's just having the portability.
Yes.
Not having to drag everything out, just a nice, light, tight little package I can throw in the back of the buggy, and
Yeah, we were talking with Ian, Jake, he's perfect for me when I take it out on the road. If I wreck a car, I put it back together, go home, don't have to worry about anything else. So.
Yeah, exactly. So like rock crawler applications, anything like that.
Absolutely.
Yeah, that's an awesome piece of equipment to have in the back of the truck.
It's another tool in the toolbox.
Yeah. Well, great, Mike. Anything else you kind of want to inform the listeners about?
No, I think I've covered just about everything.
Okay. Well, I appreciate it.
Okay. Thank you, sir.
Thank you. All right, I'm here with Jamie Skripnik. Jamie, let's talk automation. Cobots seem to be all the rage here at FabTech for the past couple of years. When you go into FabTech, it just seems like the robots are taking over. I mean, every booth you go to has a swinging arm. I noticed you guys have one over here on a UR platform. Tell me a little bit about your Cobot system.
So, you're right. When I walked in the show the first day and I walked down the aisle from the front to the back here, you're right. Just about every booth has a Cobot. And it's all stemming from the shortage of welders in the industry. People can't get qualified welders. Welders are not showing up every day. So there's that lack of support. The Cobot for us was an introduction to be able to help these companies produce parts. And I think our biggest sales pitch is ease of use. We can give this Cobot, we'll call it a tool for the welder, make it extremely simple for him to use, increase productivity, increase quality, We've partnered with High Robotics and UR, so the robot is a UR robot. We have 2 models at the show here. We have the UR10 and we have the UR20, which is just being released. It's got a little 14 inches extra reach, a little more payload capacity. The smaller one's on a 3x4 table, the bigger one's on a 5x10. So a lot more reach, a lot more flexibility for welding a variety of different parts.
Okay, and you got it mounted to a fixturing table, so you can actually clamp all your parts down. And
yeah, so the tables that we use are Sigmund tables, Sigmund 16, so meaning the holes, the 5/8 or 16 millimeter. They're extremely flat, they're nitride coated, none of the spatter sticks, and a cobot can only weld the part exactly where you put it every single time. So this table allows us to repeat the fixture in the right spot so the cobot can weld it.
Okay. Now, which type of power source do you have hooked up to it?
So on here, currently we have the Aristo 500iX with a robust feed and the U82 process controller for the welding. So it allows us to weld either carbon steel, stainless steel, or aluminum.
Okay, so you can do all 3 different types of hours.
In the smaller cobot, currently we can do all 3. We just have to change the liners and the drive rolls to go to aluminum.
For the aluminum, yeah.
The bigger package, we're going to be looking at a push-pull because the gun is significantly longer.
Right, yeah, you got to be able to, especially with 40-43 wire, man. That stuff binds up just...
Yep. So it was interesting. You know, I've done a number of demos so far with customers. I've been against competitive cobots. Some of them have really feeding issues. Bird's nesting. I put a cobot in a couple of weeks ago to customers. 2 days later, not one bird's nest. It says the other machine bird's nests about every hour, every 40 minutes. I got to pull the wire. It didn't feed correctly. With the way the gun is through what we call the shark fin at the top with the ESAB logo, it's the ease of the robot moving and manipulating without the gun getting caught. And it really allows the dexterity of the robot to move without jamming up the liner so that we don't have any bird's nesting.
So you get a smoother transition, less resistance on the wire coming out.
Much less resistance, absolutely.
Okay.
So we do change the liner in the gun to go to a Teflon liner, and we put a neck liner in the torch so that as a wear we can just change a short piece out so that we don't have to replace the entire liner.
I got you. That's pretty slick. And then obviously, you just open up the side of the machine, drop the spool in that way?
Yeah.
Or can you run off the drums?
So the way the feeder is currently set up, and it's kind of in the whole robust feed platform, they got LED lights in it so you can see how much wire is left on the spool while it's in. You open it up. It'll take a 44-pound stainless, 44-pound coil or spool of steel wire, and I don't know if it's 15 pounds for aluminum, I think. But if you want to run from a drum, we just poke a little hole in the back of the feeder. We put a quick disconnect, and we can run the wire right through and run it off a drum. There's no issue.
Okay.
For aluminum, if you're running in some of the southern states where there's a little more humidity, we can actually at night turn the feeder to put the heater on, and we just keep the moisture out of the feeder overnight.
Yeah, I thought that was pretty slick. Jamie was talking about that in the Warrior lineup. You actually have a heater on the inside of the machine.
Yeah, so in the robust feed, we can either have it on or off. In the new Edge platform, it can be on all the time.
Okay, so you can just leave it on 24/7.
We've had customers come back and said, that's a great idea, but I want to have it on all the time because we have some of the requirements for hydrogen and some of the cord wires, the metal cord wires. We don't want any moisture pickup, so we just leave the heat on.
Yeah, we run into that problem down there in Florida. I mean, it's 100% humidity year-round, to be able to keep the moisture off your wire, especially if you're working in like an air-conditioned shop or anything like that, or transitioning between one spot to another. Having that technology inside the machine, that's an added bonus.
Oh, absolutely.
Especially when it comes to aluminum.
Yep. Yeah, you don't want to pick up the moisture. I mean, the cord wires for the structural industry, we see that companies at night have to take the spools, bag them, and put them in special rooms. Yep. Now they can just leave them in and just turn the heater on. So it really helps with the operators not having to take it off, take it on. You drop it, you lose it, you decoil, you get all kinds of issues with it. So it just simplifies it for the operator.
Okay. Now, speaking of simplicity, how easy are these systems to operate? I mean, do I need extensive training, like weeks, hours? I mean, what are we looking at here?
Well, we could walk over there. Within 5 minutes, you could be teaching this robot a path. It's that simple.
In 5 minutes?
In 5 minutes.
Okay.
So we've had several trade shows. We actually did one in Indianapolis. It was a car show. A father and a daughter walked up. We gave it to her. She was 7, and she programmed the line. It's that easy. So we've kind of separated ourselves from the other competitors. They typically run the robot teach pendant. You got to know some of the programming. You got to know that you got to insert the weld. You got to have a lead in, lead out, and all that. With the software that we have, all of that's done behind the scenes. You just need to teach the points. And if you need to put in an air cut move, we can just easily transfer to an air cut move to move from one segment of the weld to the next. Save it. And the way we do it, we have parts and we have a playlist. So as you generate parts, you can add them to the playlist. So you can have multiple parts on the table, or you can have just one. It's kind of like Spotify. You have songs, you want to listen to multiple songs, you add them to the playlist, you only want one, and you can save them in an infinite amount of parts. So if you're welding 5 today, you're not going to weld them for another month. We can also deactivate them so that you can just store them so that the menu doesn't get cluttered with all these different parts.
Okay. What type of interface is this? Is it kind of like on a touchscreen or an iPad?
So it's an app that runs on an Android or an Apple device, and it can also run off a computer. But typically, you know what? Part of the sales thing we go to, if I give you this robot teach pendant and you give it to a welder, and he grabs it and he's like, okay, deer in the headlights. What do I do with this?
What am I going to do with this thing?
But, sir, if you took out your phone and I installed app, what do you think? How would you like to use that? Everybody has a phone. Everybody uses a tablet. And the interface in the tablet is really doesn't reflect robot programming. It's like I need to teach a linear move. I need to teach a radial weld. I want to do a stitch weld. I need to do a tack weld. It's very, very intuitive and easy to use and very easy to teach.
Okay, now about how do you go about inputting your settings as far as your wire feed speed, your voltage, your stick out, travel speed, all that good stuff?
So as we start to create a part, you give it a name, and then from there you can go to a library of predetermined welding conditions. And you, as the consumer, would generate these from your WPSs. You could add it. I wanted a pulse CV with a carbon steel 70S6, for example, with a C25 gas. You can go in, and then at that point, if it's pulse, you would put in your wire feed speed. You trim. You either want it hotter or colder. You can put in a travel speed, and then you can save it. So that now populates the entire program with that weld condition. But that weld condition can be varied depending on the segment. So every segment will start with a global setting, but you can go in and fine-tune it. So if you're doing a flat, the next thing you know, you need to do a vertical or vertical down, you can change the parameters just for that segment. Easy.
Okay, so from one point to the next, you can actually put in different parameters.
Yeah.
Now, can you do that with modes of metal transfer?
Yep.
Okay.
So what it does is, in this library, you can get quarter-inch fillet, for example. When you label it, then you can just go back and use that on any part moving forward. If you go into the part path and you make a change, it asks you, do you want to make it for the global or you want to just make it for this part?
Just for this. So you can actually edit one line code just for a custom part or something to that effect without having to change everything down the line.
Correct.
So single time change.
Yes. Yep.
That's fantastic. Now, what modes of metal transfer can you actually run on the system you have set up over there?
So we have standard CV, and then we have pulse. So we can do pulse carbon steel, pulse stainless steel, and pulse aluminum. Okay. And then within there we have the nickel bases that are all part of a synergic line that we can choose from in the stainless family. So it's not an issue. Okay.
Well, now because you can do both of those, you could also run a spray if you needed to. If you wanted to run a flat spray for a horizontal fillet weld or a groove or anything like that.
Yep. It's one thing that's interesting about the Aristo. We have just a conventional CV and pulse, but within the pulse we have what's called pulse on pulse. So customers have it the ability to create that row of dimes. Sorry, it's not pulse on pulse. It's called super pulse. What we can do is we can mix a spray and a short arc. We can mix a short arc and a globular, depending if we're out of position. So we can modify 2 segments of a weld characteristic to be able to overcome challenges in the welding. Have it a little hotter, but we don't want it too hot so it'll all fall out. So we can adjust it, and we can have both of those within the Super Pulse for aluminum.
Yeah, and some of the benefits of that is, for instance, when you're going out of position. If you want to go from a regular spray transfer into a pulse spray, you're able to do that right on the fly, just from one line to the next.
Well, actually, the one line, when you teach the next point, there'll be a transition there, so that's when you would make the change.
Okay. So then when you program and run the robot, it would actually complete one weld, the settings would change, and then it would
go to the next one.
Go right into the next one.
Yep.
Well, that's slick.
Yeah, it is. It is pretty cool. Moving forward in the coming couple months, we'll have the Edge platform, which will allow us to have a little bit more selection. We'll have the root pass, the speed pass, so we'll be able to choose those processes within the controller so we can have a little bit more variety of the welding conditions.
Okay, and the great thing about these cobots is they're super portable. I mean, you said they're on a segment table. They've got 4 wheels on them, so you can move this all throughout the shop. So, you don't have to have a dedicated space. As long as you can run the power to that system. Yep. You can take it everywhere.
Yeah, well, it's also a connected product, and that's part of the benefit of having an app running, so we can go through the cloud down to it. So if you're going to move it around the shop, we just need to make sure we have connectivity to be able to supply the internet connection.
Okay. Now, do you have to program the part on the table, or is that something you can do in a separate software, like in an office, if you had some really complex parts and stuff like that?
The cobot is really intended for the welder. It's a tool for the welder. So we'll keep it simple, and we won't have any offload programming software. I mean, we do have that within the ESAB portfolio with Octopus. You can input a 3D drawing. You can generate all the path for the robot. You can load it in the cobot. But today, as it stands, the cobot is just intended for the operator to teach the path and to run it. So it keeps it simple. So it's for low volume, high mix. We only need to make 10 of these, 10 of those. I don't need to spend 3-4 hours programming it. I can spend a few minutes and weld it, and then just save the program for a later date.
Okay. Now, how does it deal with material warpage or like pore fit up or anything like that?
So as it stands now, unfortunately we don't have seam tracking. And when you consider it's only on a table that's 3x4, how much do I really need to seam track a part that's properly fit? Mm-hmm. And then I think it's true to be said in any robot application. Part fit up is key.
Critical.
You put in, and if you put in a part that's badly fit up, you're going to get a part that's probably not to tolerance after the fact. If you put a part in that's nice and tight, it's no issue. And the distortion, because you can stagger the welds, I mean, that's up to the welder, and the welder knows those kind of things. He knows where to put the welds to minimize the distortion, so that's the advantage that we have, that he can stagger them. It's not, it doesn't have any AI, it doesn't figure that out for you, but the welder typically knows where he's got to put the welds to keep the part to tolerance.
Okay. Now, if a customer were to buy one of these systems, does it have to be on a table, or can I just purchase the arm and the power source and then mount that to my own table in the shop?
So what we have done is we tried to make this as simple as possible. We have two units. We have an air-cooled and we have a water-cooled. When you buy it, it comes in a cardboard-wrapped box. There's a little barcode on the front that you pick, and there's a step-by-step process to put it together. So it does come with the table, comes with everything. You can easily take the robot and mount it on another table. I had a customer that said, I got some bigger parts. He'd already had Sigmund tables in his shop. He moved it from the small table, put it on a 5x10, cut a couple different zones, so it's easily transferable. The cobot could also be mounted overhead. It could be mounted vertically. You just need to change the gravity in the controller so it knows where it is.
Okay. That's pretty slick. And all of your machines are on a universal or UR platform?
That's correct.
Or do you integrate with other manufacturers?
Well, currently, within the robot portfolio, we have the device net connectivity. So if we take an Aristo 500, we can put it on an ABB or a Yaskawa or a Fanuc. But for the cobots, it's strictly with UR for now.
Okay, and then you guys, what other types of automation do you all at ESAB have?
Well, I've been working in the automation division for a number of years. We do sub-arc welding manipulators. We've been heavily involved in the wind tower industry. We do a lot with the shipyard industry with a tandem ice process, and that's used to help helps to reduce the distortion in the panels, which is significant. We do submerged arc tractors, we do MIG tractors, we have arc air tractors. We have a full plethora of equipment that we can use in a variety of different segments, and that's probably the funnest part of my job. Is one day I could be at a wind tower plant, the next day I could be at a pressure vessel plant, the next day I could be at a structural steel facility looking at different applications. So we have a great variety of product to fill the needs in the automation line.
Okay, that's fantastic. Yeah, I like sub-arc. I never get to use it much. I get to play around with it at the when I was teaching, because we had a sub-arc system at the school. But I never get to go out in the field to see it. We had one manufacturer; they had a massive sub-arc system, and they built pressure vessels, and everything was rotated. But it's really cool to see that. And what a lot of people they don't consider it to be welding, but it is.
There's no visible arc. That's the difference.
Well, yeah, but then they're like, oh, that's not real. You're just pushing a button. Yeah, but you got to understand what all them little knobs and dials do. Like the burn back, the offset. The amps, the volts, the travel speed. I mean, those are critical. You get in the right amps and volts, and then you set it down with the wrong travel speed. I mean, you could blow through a half-inch thick material in an instant.
Oh, you can also have the slag stick where you need a jackhammer to get it out.
Exactly, that's the worst.
One of my first installations on a welding manipulator was a customer in Michigan, and the operator that they had selected to be the operator was kind of, I don't want this job. I don't know sub-arc. I don't do it. 2 weeks later, they put a posting up for some more operators. Everybody in the plant applied. They noticed he was wearing clear glasses. He had short sleeves on. There was a fan blowing because he didn't have to worry about blowing the shielding gas away. It changed a lot of people's attitude towards sub-arc, the higher productivity, the consistency in the automated process. And I mean, you still have to be qualified to do it, so it's not like you can just take anybody and throw them on there. And you're right, with the variable parameters, now with inverter-based power supplies, we can change the waveform, we can modify the bead profile by just changing welding conditions. You need to know what you're doing.
Yeah. Well, I mean, the same thing with your flux and wire compositions. You put the wrong flux in there, you're going to get a bad weld.
Many times we get an application where a customer asks us to come in and take a look at what they're doing. We'd like to quote a piece of equipment. This is the wire and flux we're using. Can you give us an equivalent? And we'll always step back and say, what are you welding? What are the welding requirements? Let's validate that what you're using is actually what you're supposed to be using. Because a lot of people just use what they use because that's what they've been using.
Yeah.
And there's a lot of advancements. I mean, I did a job where we were doing some box columns, and the customer had porosity issues. He was using a neutral flux. I looked at it a little bit more rusted and he needed. I said, why don't we go to an active flux? We'll get rid of that issue.
Pull out some of the impurities.
And the customer at the end, he wanted to hug me. He says, Jamie, you know how much time I spend fixing these little discontinuities, and I have to deal with it. Now I weld it, it goes to the next station, I'm done. So it was just looking at it and understanding what the application was to make sure that we had the right filler metals for that choice.
Yeah, it's value added for the customer at that point. I mean, like you want to sell them what they want, but you also kind of want to educate them, especially if they're having issues like porosity.
Yeah. In my role as an equipment sales guy, I always want to sell the razor, but we're ESAB as a global, we're chasing the razor blades as well. And that's always part of my job to make sure that I can understand the customer's application, bring in an application engineer from the team, make sure we get the customer the right piece of equipment that does exactly what he wants it to do. Because if I don't do my job right, he doesn't buy the consumables, and there's that revenue stream that we could lose. So
exactly.
we work closely together to make sure that we give the customer exactly what he's looking for.
Yeah, and then joint configuration and fit-up is another massive issue with sub-arc welding. I mean, if you don't have the joint fit-up just, set in there correctly, you could start getting cracking all down through the part.
Nowadays, with some of the productivity customers are looking for and some of the processes that ICE is an example, it's a sub-arc process where we introduce a third wire between two hot wires. The joint volume can change, and we can minimize the joint volume to increase productivity. So there's a lot of things we can look at to help the customer. You don't typically need a 60 degree included. Maybe we can do a 50, maybe do a 45 degree included. We have narrow gap systems now that we can weld a 7/8 opening that's 10 inches deep, as opposed to, imagine something that's 10 inches deep with a 60 degree included. You could put 200 passes in there, where we go and put maybe 40, 50 passes.
Wow.
So there's significant advantages and different things to look at. And everybody nowadays is, how can I make this faster? How can I increase the quality? How can I make it faster without making it more complicated?
Yeah, I need to make it faster, better, cheaper than the next guy.
Yeah, because at that point, everybody's buying the steel for virtually the same price. It's labor that's the portion now. We have a customer, we just finished installing a large welding manipulator, and he says, when I'm running this, as opposed to the way I could run it, I take a week out of production, out of a 3-week job. An entire week's worth of production. So imagine the cost savings on that.
Now, go ahead.
No, go ahead.
I was going to say, when you have that third wire coming in, is that a hot wire or is that a cold wire?
It's
just
absolutely
for deposition?
Isolated, so it's just pure filler metal.
Okay.
So we use the excess heat from the two hot wires, and we use it much like in a TIG process or an oxy-fuel brazing process. We add that filler metal to the joint to increase the deposition rate. So for any given wire parameter, we can increase the deposition rate by 50% and not even changing the welding conditions.
50%?
So the two hot wires run in, and let's use 1,000 amps, for example. They're coming in at 100 inches a minute. I have the middle wire, which is the same diameter as the two outer wires, and if I set the wire feed speed for that wire at 50 inches a minute, I've increased it by 25% because it's half. If I increase it to 100 to equal the two, I've now added 50% wire into that joint, and I didn't have to change the amps or volts.
Man, so you get a lot more weld deposition. That, at the end of the day, that's what it amounts to, is like how much metal are you actually putting into the joint?
Absolutely. So the ICE, the acronym is Integrated Cold Electrode. And there's a fallacy that, we're actually cooling the puddle. We're not. We're just using the excess energy that's there to burn that wire off.
Because you may not need 1,000 amps for that joint. So it's actually cooling that puddle down a little bit, but you're still using the same amount of amperage.
That's right. And what we're finding is that, we inherently, when we start to add more metal into a joint, we can travel faster. You travel faster, what do? You lower the heat input. So we can increase productivity. If you're going to increase the deposition rate, you end up using less flux, so you can reduce the flux consumption. Up to 20% we can reduce the flux consumption on a joint configuration.
Yeah, and a lot of times, especially if you've got to meet certain impact testing, you want to decrease your heat input.
Absolutely.
Otherwise, you're going to make it too hard and it's going to shatter.
Yeah, and what we're finding that there also is a little less dilution with the base metal. The wire feed, the wires, we can control the chemistry a lot better than we can the plate chemistry. So with the increased travel speed, the increased deposition rate, we have less dilution with the base metal. We have a better mechanical property at the end of the day. So we found, and I guess at the beginning it was kind of, we're looking into it and we're like, wow, why? With these wire combinations, we're getting great mechanical properties, great Sharpies, so it's a win-win.
Okay. Now, how many heads can you put on a single unit? Or how many heads have you had the chance to put on a single unit?
So, well, if we have a welding manipulator, we can have a tandem setup. We may have a single lead DC, and typically we want the DC in the front for the punch. We want penetration to tie the joint together, and after that we would fill it with the tandem trail, which would be AC. We've had instances where we had 2 wires in the lead, 2 wires in the trail. We can do 3 wires in the lead, 3 wires in the trail. We have pipe mill setups where we have 5-wire setups. So there's really an unlimited possibility. It really boils down to what is the joint configuration, what are the requirements, what are the mechanical requirements. We've had structural steel instances where we set up a tractor, for example, with a single wire 532 and you're 18, 20 pounds an hour. Customer come back and says, I need a little bit more. That's okay, well, let's go to a twin 332. It's actually a 30-second bigger, 532 versus 2 332. We get him into the 40 pounds an hour. He comes back, I want a little bit more. So, well, we can go to AC. Let's go to AC. He says, I want a little bit more. Okay, let's vary the waveform. Okay, I want a little bit more. How about we go to ICE? Great, I want a little bit more. I want to parallel 2 power sources because I can give this. So we went from a single power source, 700 or 800 amps, to 2 parallel power sources at over 1,400 amps. We go from 18 pounds an hour, we go to over 100 pounds an hour deposition rate.
Jeez. Now, how much metal can that actually carry? Can a joint actually carry safely without messing up the mechanicals? Because that's a lot of molten metal there in one area.
The columns that are being used today to add either extra floors to buildings or removing columns and just putting bigger trusses in is nothing like you've seen before. Plates 4 inches thick, 4 inches thick, laminated, 5 wide. You get a beam that's 20 inches thick by 20 inches tall. So the weld volume, I've seen beams where there's 5,000 pounds of weld metal in the beam alone. So increased fillet sizes, a partial pen fillets, 4 1/4 inch fillet sizes. Everybody's used to 1/4 inch, maybe 3/8, 7/8. 1 inch fillet is big. I've had to have customer have to have custom made fillet gauges to do 4 1/4 inch fillets.
Now, is that in a single pass application
or
multi-pass?
That was 72 passes.
72 passes.
Yep.
Man,
yep.
What length?
Oh, it was 40 feet long. They got a couple small sub-arc gantries, and they got 2 heads, and they just travel back and forth, back and forth. So the operators basically are just visually checking, making sure he's peeling the slag. The vacuums automatically pick up the unused flux, and then when he gets to the end, picks up the heads, goes back to the beginning, just repositions the wire, and away you go.
Now, how much of that flux that it's recuperating or reclaiming, how much of that can actually be reused?
100% of it.
100%.
Yeah, so what isn't recycled is the slag. The slag is now waste, but the flux with the recycling systems we have, I would say we probably get 90% of it, of the unused flux. Now, in a ratio, you may go 1 to 3. For every pound of wire, you use 1.3 pounds of flux, but that's because it's consumed in slag.
Okay.
So the more we can recycle it, the more efficient it is. Welding on a drum or on a pressure vessel is a little tougher because the way that it is, and then you have some drop off. It's just the way it is.
Yeah, it's got to rotate.
But in a flat, we can pick up virtually everything that's unused.
Okay. Yeah, I mean, that's a big cost savings to the customer.
Oh, absolutely. Absolutely. And with the systems we have now, on a smaller gantry, we have a couple heads. We have a pumper tank. We just fill the heads automatically, so the guy's not having to manually fill the hoppers. So we have much longer duty cycle. We have heaters in the hoppers so we can maintain or, minimize.
Keep the moisture out again?
Keep the moisture out, absolutely.
Yeah. Moisture seems to be a problem in every welding application. You've got to keep the moisture out.
Yeah, well, flux is hygroscopic, so if you don't pay attention, you're picking up moisture, you got hydrogen, then there's a plethora of issues that come with that. We've had installations, and I was down on the Gulf Coast, and we were doing an installation. The guy says, we just bought a brand new compressor, everything's good. You go to the drop, you open the valve at the bottom, and 5 gallons of water come out of the line. Well, the compressor's in another building, sure, but it's got to transfer. You're in the Gulf Coast, there's lots of humidity. Moisture in the lines is not good for sub-arc welding.
Yeah, so we several dryers set up.
Yeah, so we set it up. We put a local dryer to that specific spot. No problems after that.
Solve the issue.
Yep.
What's one of the coolest problems you've worked on with sub-arc?
I got called out after September 11th to New York City. We were working on, I can't remember the bridge. It might have been the Harrisburg Bridge. And I'm probably getting the name wrong, but they had set up a system where the generators were at one end of the bridge. They're replacing all the deck plates. The tractors were at the other end of the bridge, and as they welded plates, they kept bringing the tractor closer to the generator, and all they did was coil up the cables. And the closer they got, the more coils they had. We created a great big inductor. We started to lose voltage in the weld. The operators were complaining that the system wasn't welding like it did at the beginning. You get out there, you understand, and you stretch out the cables, and you go hit the weld, and they look at you like, well, what did you do? I said, it's the cables. It's
I
physics.
moved the cables.
I can't.
I pulled the magnet out of the system.
Yeah, so the system was thinking that it was welding at a certain condition, but it couldn't keep up because the inductance in the cables and that, 200 feet of cable coiled up, much like if you see a stick machine when you're gouging, when they hit the go button, those cables bounce off the side of the machine. Well, when you have, 500 or 600 amps in a sub-arc weld and those cables are all coiled up, that was probably one of the most interesting ones that I got to. I got to experience a little bit of New York City and the Union and being on the bridge, and that was interesting.
How long did it take you to figure out? Was it like you walked up and knew what the problem was?
Well, I had talked to them and I had seen some pictures and I knew what the issue was, but they didn't believe me. So when we went out there, the guys went for lunch, we laid out the cables, we come back, and the sales guy that was with, he goes, Jamie, please, just don't tell them you just straightened out the cables. Tell them you looked in the system. We will eventually tell them, but the operators were a little challenging, and he said, so just let them run, and then if it works good, we've done our job, and then we can explain to the site supervisors that these are things that inherently you can't do.
Yeah, until they coil the cable up again. That's what a lot of people don't realize, too, is, on the opposite side of that, the further away you get away from the power source, the bigger the cable that you have to have or the more amps you have to throw to it. So, if I need 500 amps down there, 200 yards away, I may have to set the machine 600 amps, depending on the size of the cable that I got, so that I'm actually getting 500 at the arc.
It's interesting. The amps is not as much, it is not as critical as the voltage. You have voltage drop over the length of the cable. In our systems, we have voltage sense leads on the head and on the ground. So regardless of the cable length, we pick up the voltage at the arc. So if I'm asking for a sub-arc weld at 32 volts, the power source could be putting out 36 volts, but the loss in the cables
compensate for it. So we inherently take advantage of that and set the controller, and it picks up, and then we hit the right, what you see is what you get. You're asking for 32, you measure, you get 32 volts, even though the power source may be putting out 36 volts. Some of the machine's constantly monitoring that and giving you exactly what you need so everything maintains consistency.
I've had a couple installations where the foreman has kind of said, why are these machines so smart? The older machines were just dumb and they didn't really care how the grounding was. I said, well, it's technology, right? The iPhone 1 that you had is no longer, now it's the iPhone 15. Technology changes, things get faster, the machines get smarter. They give us better regulation on the power source, but when something's not right, it's not right.
You're also getting better materials, better components and everything into the newer equipment as well, right?
Oh, absolutely.
As far as all the microchips and everything, they're becoming a lot more efficient.
Oh, there's no question about it. When I started, a few years back, when a PC board went, they were soldered on components. You could see that it was burnt. You can change it. Now everything's surface mounted. The quality of the product, the durability is significantly higher than those old PC boards. I was service manager for a number of years, and the amount of times that we had a board failure back then was much higher than it is now. Now, when something's going wrong, the guy says, well, I think it's the board. I go, no, I think there's something else wrong. And in sub-arc, the biggest issue that we'll see is grounding. Grounding. They just take a clamp, they lay it on the part, or they attach it to the part, don't clean the spot off. All that rusted mill scale causes the resistance. The resistance makes the cables hotter. The hotter that gets, the more resistance they get, the issue amplifies. So it's, the first question you ask them, so when you remove the ground clamps, oh man, I got to put leather gloves on. I burn my hands. There's an indication right there, and many calls start with that.
Yeah, that's what I do troubleshooting for clients all the time, and I've got one of the FLIR infrared multimeters, and the first thing I do is, okay, go ahead, weld, let me see what the problem is, but I'll turn that infrared camera on and just check around and look at their cables first, because if the cables are hot, they're getting resistance in that wire, and that's robbing them of the amperage at the arc that they're getting, and they don't realize it until the nut on the ground clamp, that red indicator light comes on because it's so hot it's melting the metal.
Well, you'll get the casing on the wire starts to melt, the copper starts to discolorate. You asked me about interesting applications that I've had to go. We did an installation at a Yellow Goods. They were making farming equipment. Had a robot head and tail stock, 2 robots welding on one part. One welded perfectly. The other one had all kinds of issues. I get in there one day after they're in welding, and I kind of lean up on the head and tail stock to kind of, I'm thinking about what's going on. And I put my hand on the grounding, and I burnt my elbow. And I looked at that, and I'm going, wait a second here. We took the cables off, we cut the lugs, we recrimped them, we put it on. Perfect weld. Just bad crimps.
Yeah.
Bad crimps.
It's amazing how, the simple things, everybody wants to blame the machine first, but a lot of times it's operator error or, negligence on the operator's behalf, things that they just don't know to look for.
Well, that's a great point. We always assume the worst. When a welding equipment is not welding, it's because it's the welding equipment. could be a loose drive roll.
Yeah.
So amps are fluctuating. Could be a bad ground, and a lot of that is the case in many instances.
Yeah, I tell people like 90% of the time it's the pilot, not the plane.
True story.
Well, Jamie, it's been an absolute pleasure talking to you. I appreciate you taking time out of the show to come over here and kind of chat with us about automation.
No, I appreciate it. Thank you.
Thank you.
All right, cheers.
All right, so now I'm with Dan Calvin. Dan is a specialist in digital solutions. Dan, I'm a welder. What are digital solutions, and why does that matter to me?
Well, do you remember about 5-10 years ago when people started talking about smart homes? And we
Yes.
all looked at them like, I can change my thermostat. I don't need to do it on my phone.
Yeah,
And now everybody changes the thermostat on their phone.
exactly.
Wireless printing, wireless. It's the same. You know, it always has amazed me for many years how people, if you go talk about machining centers, they know how many grams of material, how many ounces of cutting fluid, how to the second how long it takes to create a part. Welders, we've always been told that, well, how long does it take? About an hour, about 10 minutes, about 15 minutes. That's what Digital Solutions does. Digital Solutions makes sure we're doing everything correctly and make sure we know exactly how much money we're putting into that part, how much we need to sell that part for, how much wire we need to make that part, how much gas we're going to need to make that part, how much time we're going to need to lay that part out or that assembly out. It gives you all of that data, not just what you should do, but did you do it? So did we, what is a good plan, and did we execute on the plan? And we closed that loop.
So it's a monitoring system.
It's a monitoring system, but that's what a lot of people have, a monitoring system. Which
This is like a process improvement monitoring system.
This is actually productivity and improvement and monitoring and everything else, because we start with Weld Cloud Notes. So Weld Cloud Notes will create a WPS. So we know what we need to do. Then we have Weld Cloud Assembly, who will maintain what welds need to be welded and what we average out of bounds, where we below average out of bounds. What welds should we look at that weren't welded to the spec? Do we need to go backwards and look at things? Was everything up to snuff? Was it great? Perfect. Then if you have ASME work or you have bridge work or you have anything that needs to be tracked, we can track the heat and lot numbers of the material. We can track which spool of wire you use, what kind of gas you use, who welded it, what amperage, what voltage you welded it at. We can track every aspect of the weld. Even 20 years later, you can come back and find it and find out how you did.
Now, that's got to be great for a company from a litigation standpoint. You know, if somebody's accusing you of not performing it correctly or not doing it correctly, you actually have written viable data that explains this is the amps we use, the wire feed speed, heat and lot numbers of the material, heat and lot numbers of the filler metal. Like, here's all of our stuff.
Exactly. And we closed the loop. So before, that used to be an event, right? People would manually write down this information, that information. They accumulate it all. They give it to this person, who gives it to that person, who writes it down, who gives it to that person, who enters it. And you have multiple facets of failure in that chain. Now it's all done automatically. It doesn't take any more of the welder's time. It doesn't take any more of the management time. We tell you how you should weld it. With some of our equipment that's already equipped with this product, it'll make sure that we do it, and it's all on its own. We can monitor which welders are certified to do what product. You know, are you certified for stick but not certified for flux core? Well, if you go in and you have your badge and you try to badge into the machine to make a weld you're not qualified to weld, it won't let you. So you don't make the mistake. You know, rework and mistakes are far more expensive than just everything else. So let's not have that, and let's keep track of what we do and what we've done right. Let's keep track of that for however long you need to keep track of it.
Yeah, rework costs 300% more than it does to do it right the first time.
Exactly.
So now you're saying you're tracking all this stuff, the heat and lot numbers, the welder, the certification, the WPS. How do you go about logging in this information? Is there like a scanner on the machine where I can bring up a box of filler metal and scan that right into the system, or how's that work? Or do you have like one central area where everything gets logged?
Well, you can use a scanner. You can use your phone. You can use whatever type of. There's a few devices that you can use to scan barcodes. We can take off our cutting machine and we can put a barcode on a heat and lot number of material or a piece of material. So when that gets to the weld station in theory, you can scan that barcode and you can say, okay, I've already set this machine up with that wire. I'm using that gas, and you've logged into the machine with your badge. So now we know what wire, what gas, what welder, what base plate, when you welded it, and how you welded it. And then that gets reported up and in this case it's cloud-based, and you can export it to Excel, you can export it to any other database you need to export it to, or you can just look at it through our system on your iPad or your phone. You set up a report. Let's say you're managing a shop with 500 welders. Well, you can come in on Monday morning and you get an email from ESAB Weld Cloud or Indu Suites, and it's going to tell you, click this link, and that link's going to tell you what welds you made, what welder made what welds in the last 7 days, and what was his productivity, what was his throughput, how many welds of what welds did he make, what machine was out. We also have Weld Cloud Fleet. So Fleet monitors the welding equipment. When is it up for a PM? How many hours are on it? How much time has it actually been used welding? And what do we need to do next? You can set up, I'm going to change drive rolls every 300 hours, 3,000 hours, 30,000 hours. You set it in there, and when it comes time for that machine to have the drive rolls changed, then the outlet guides or the contact, whatever it is, it tells you.
It's kind of like your car at this point. You know, you're due for an oil change. Check the engine light.
It's exactly like that. Instead of guessing and just either waiting for a failure, which puts you out of work, or just replacing it before it needs replaced, which just costs money you didn't need to spend, we can put it in there. You can put the entire service schedule for your equipment or your PM in the system on the things that we automatically track a lot of things. But if there's something special that we don't track, you can add that to it and make it a prevent and planned hours, days, calendar, arc on time, however you want to base it, and it's going to tell either yourself or the maintenance team when you need to take care of that machine.
So you can stay ahead of the problems before they even occur.
That's the whole idea.
Okay.
Predictive maintenance.
Yeah. Now, is this part of like Industry 4.0?
It's Industry 4.0.
Okay, so that's exactly what it is Industry 4.0.
Yes.
The smart machines.
It's the smart machines, exactly.
Okay. Now, do you operate this? You said it's cloud-based. I'm assuming it's coming in through Wi-Fi or Ethernet. I know some of the other machines. I talked to some of your colleagues today. They run off Ethernet Ethernet for networking, or they're also Wi-Fi based.
It's both, and you don't even have to use Wi-Fi if you want. You can also have. We have the same feature in our new power supplies where you can plug in a USB stick and download the information if you don't want it in real time. If you want it in real time, we put it up in the cloud and you pull it down on your phone, your iPad, your computer, whatever you want.
So I can run a report whenever I need. Like every Friday afternoon, I can walk out and see what happened, all the way from Monday morning up until that point.
Exactly. You can look at it for the week. You can look at it for that particular plant. You can look at it from anybody welding stainless. You can look at it for anybody welding in that area of the plant. It tells you which areas of the plant did what. So what does that help us do? Well, maybe we have too many guys tacking and not enough guys welding. So it'll actually give you a graphical display on what amount of time was spent doing what by how many people.
Yeah, a lot of people think that arc on time is about 80%. It actually turns out it's more about 20%.
We'd sell a lot less if it was 80%.
Yeah. You'd sell a lot less if it was 80%?
We'd sell a lot less equipment if it was 80% and a lot more filler metal, I'll tell you that
true.
much.
That's true. Yeah, but it's about 20%. I ask my students, like, how much time do you think you're going to spend welding? Oh, I'm going to weld all day. No, actual arc on time. How many hours of that day? Like, what percentage-wise? And it works out to be about roughly, and I think 20 is being generous. It's probably closer to 10.
It's not where you think it would be.
Yeah,
that's for sure.
But now, as a company, I can actually see where my waste is, or what they call in Japan, muda. I guess you talk about the Six Sigma and all that stuff, kind of incorporating into Industry 4.0. You start figuring out where your waste is. Where's my downtime occurring? Now you're increasing productivity, you're increasing profits, you're decreasing unnecessary movements, unnecessary maintenance. Because if I can look at it and pre-plan all my schedule and maintenance on my equipment, I don't have any downtime.
Exactly. Let's say we look at this and say, why is that guy not welding more? It's not always about the welder. Well, you go to the welder and say, what's happening? Well, fit up's really poor. And now we know that our problem is downstream that we're paying for with the welders. But it allows us to identify where the issues are so we can correct the issues. And that's the most important thing. You can't fix what you don't know is broken, right? You go to the doctor, you have to get a diagnosis before you can get a cure. And we're doing the same thing. People come to us and say, I need 10 more welders. And we're looking around going, I see a lot of them not welding. Maybe there's a different problem here. Let's really look at what you're doing and where the problem is, what's the pain, and let's try to solve the pain by going back to the problem. And what Indu Suites or Digital Solutions allows us to do is successfully, correctly identify what needs to be corrected, and then it lets us do that.
I like having access to all that data. Now, is this something that comes standard on all your equipment, or is that like a a subscription-based plan?
There's parts of it that come with all the equipment, and there's parts of it that's subscription-based. So we got to look at what the customer wants to find. Just having data is not good. Maybe we give him data he doesn't want. Maybe he gets data that he does want. But Fleet, for instance, with our Warrior Edge, comes activated. So you can always look at how that machine is operating, the maintenance schedule. You can get updates or upgrades to the software done through the web, so you don't ever have to plug in another USB or a cable. You just get it pushed down to your machine, and the machine's going to ask you, hey, I got update version 8.2 of the software. You want me to install it? Yes or no? If you say yes, and as soon as you turn it on, it's going to install it. It also looks for corrupt files, so if there's a corrupt file on your machine, we're going to pull that off. It's really bringing, some of the technology you have in your hand with your iPhone, it's putting that in the welding machine.
That's crazy. Now, how long has this technology been around with ESAB?
It's been around for a few years, but it's gotten more and more features, so now we've got a full process where I can close the loop. We always have to close the loop, right? Even if it's a handheld welder, it's a cobot, like you talked to Jamie about. I can tell the cobot what I want it to do, but how do I make sure that it did what I wanted it to do? And that's what this does. From weld notes to weld cloud to assembly, all the way back around, and say, I asked for this, I got the quality I'm looking for.
So you can link this up to your cobots as well.
You can link this up to any piece of equipment that welds with ESAB. And we also have a universal kit, so I can hook up any piece of equipment you have in the shop that's not ESAB.
Oh, really? So
Right.
as long as it's got like an Ethernet port or a USB or anything like that, you can put that software on it?
No, I have a box that goes and it plugs into the weld leads, and I monitor what you do with that welding machine through this box.
Okay. What's that system called?
What? Pardon me?
What's that system called?
The universal connector, ESAB's universal cloud connector.
Okay. So I can put that on any machine that I have.
You can put on engine drive, you can put on if you happen to have a competitive machine, you can put it right on it.
Just clip it right onto the leads?
Yep, clip it right into the leads.
And then it keeps track of everything.
Keeps track. Where it's at, where it's been, and then keep track of where it's actually at in your shop.
So I don't have to buy a bunch of I don't have to replace everything that I have in my shop. I can just switch over to this service and just get one of those universal boxes and plug it on, and now everything's being monitored.
Exactly. And we can't say we're going to sit here and help fabricators if we're not willing to play with the others, right? So we're here to help the fabricators, and part of that is helping them with what they have, not just having to replace everything they have. So we made it to work with anything.
Now, does that link up to like CNC plasma equipment as well, so you can track that, or lasers, or any of that?
We have Cut Cloud, which
Okay.
pretty much does the same thing when you cut, yeah.
Oh, fantastic.
So it'll run on our cutting machines, it'll run on welding machines, it'll run on any of our welding machines. If you have a 20-year-old ESAB, we'll click it in and it'll sync right up.
That's very impressive. Do you find that industry's pretty accepting of this new technology? Or, I mean, a lot of people getting on board because they want to start tracking this data and see where their waste is and where they can shore the company up?
They are. It's in the adoption stage because they have to have it. You can't be more efficient. We can't compete on the world stage if we don't get better at what we do, right? And it's back to that. You got to know what you got to do differently, what you have to do better. And this is what points you in the right direction to spend your calories and your time fixing things or addressing things or supporting or adding to. You may have 25 guys in tacking and 10 guys in welding. You're finding out that you're getting far more output in tacking. Why? Well, I need more people over here, or I need fewer people here. Maybe we split the difference. So it gives you a graphical interface and a data-driven solution that tells you exactly what you need to do different.
Yeah, and a lot of companies that don't want to start adopting this type of technology, they're going to be left in the weeds. Just because
Yes.
they're not going to remain competitive. You can't remain competitive if you can't figure out where you need to improve your processes.
Welding manufacturing efficiency shouldn't be a roll of the dice. It should be just as up-to-date and accurate as other parts of our business.
Yeah. Now, this is the type of technology that needs to be exposed to, like your certified welding supervisors, so they can go out there in the shop and kind of implement a lot of this stuff, implement these variables. That's why I think the CWS is kind of one of the most undervalued credentials within the welding industry. Like, you need somebody out there that can look at this data, be able to interpret it, because you're not going to be able to send this up to some of the people in the office. They're not going to understand, okay, I've got this data, what do I do with it? How do I start implementing these changes? What can we do to implement these changes?
And it actually gives some guys in the head office, maybe it's a commercial guy, right? He can look at the last time he did that job and how much he spent. So now I might not know exactly what I need to do, but I know what I did the last time, and I know how to do it better the next time.
Yeah.
So if you quoted a job to take 400 hours and it took 550, wouldn't you like to know it? And if you knew it, wouldn't you like to fix it?
Exactly.
There you go.
That's actually the motto of the podcast, to make every weld better than your last. So but it's the same thing. Make every project better than your last. Make every bid better than your last. Make every contract better than your last. What gets measured gets managed. And my buddy Charlie Cross always says that. You've got to be able to manage the data or look at the data. And at that point, you can go in there and you can start making the necessary changes.
Exactly. It's a help. It's not the end-all, do-all, but it actually puts you in the right place.
Yeah, but you can access all this information through an app, like you said, right on your phone. So the supervisor doesn't necessarily even have to be in the same state. I could be up here at FabTech checking on my welders back at the shop, checking their production levels.
Exactly. And you can share it. If you find something specific to share with somebody else that may be in production or painting, or we can keep track of what job's coming through the shop, and you can know about when you're going to have it and plan better from the beginning to the end.
Yeah.
It's really a powerful, powerful tool if people give it a shot.
This is something industry's pretty much going to have to, like I said, they're going to have to adopt that. I remember, when the internet first came around, like everybody's like, who's going to need that? Why would everybody need a computer in their house? Nobody's going to need a computer in their house. And now we went through that whole stage of everybody had a computer in your house, and now we're going to a stage where everybody has a cell phone in their pocket. You really don't need a computer at the house for the most part. You're carrying it around in your pocket all day.
Exactly. And it's powerful. I can tell who's welding, what they're welding, and how they're coming. And even if you're a third-party guy, say you've hired a job shop to build a project for you. You can even share that data if you're a job shop. Here, I'm going to share my accountability. You can log on to my program and look at my productivity on your job.
Yeah, that's going to help the employees at the end of the day too, because now I know who to promote. I know actually who's getting the information or getting the job done.
Exactly, it's that powerful. Sky's the limit on where we're going to take digital solutions and then do suites in the future.
Awesome. Well, Dan, it's been a pleasure talking to you. This is really valuable information. I had no idea that this stuff existed, so it's great to see that it's out there and learn how to use it.
Great. I look forward to showing to you.
Thanks. All right, so I got Martin Denault with me, and we're going to talk about filler metals. So, Martin, thanks so much for coming on the show, taking time out of the day. But one of the questions I get quite a bit on Instagram is selecting the right filler metals for doing cast. I mean, everybody knows for regular mild steel, I'm going to use some 70S6 for all my MIG and TIG applications, or 7018, or depending on the process. But once it comes to cast iron, I can't use those electrodes. I can't use those typical electrodes that we use all the time for everything else. So when we get into cast, like what type of? Let's start with like cast iron.
Yeah, so with cast iron, there's a couple different options there. We cast iron is very strong, it's hard, but it's brittle. So we need to treat the material properly, preheat it, and just as with any thicker section material, we need to worry about that. But then we need to pick a filler metal that is will deal with the stresses that are in that cast iron and give and allow it the ductility to move, because you're not going to get any bending in the cast iron.
Yeah, it's got special characteristics.
Yeah, so we'll look at primarily like a nickel alloy, like 55% nickel, 99% nickel, something that is going to stay soft and bend, and all the stress and changing in the part from welding will that nickel alloy will allow the part to deflect there. It has the strength and it has the ductility to allow that bending, where the cast iron, if you try and bend it, it's going to break.
Right.
So when we weld cast iron, you can use cast iron rods, but there's risks associated with that, cracking and stresses. Going to a nickel alloy, it's easier to weld, it's easier to clean up, and you don't have these problems with it cracking after the fact.
Okay, now what about, is cast steel pretty much the same thing?
Yeah, and cast steel is a much cleaner process. With cast irons, you could have nodules of carbon in it that's what's driving the problems that people have when they're welding on those. Cast steels are typically cleaner. Cast stainless or cast aluminum, again, it's cleaner than a cast iron, metallurgically. But there are problems associated with those, and just to give your audience a resource, if they look in for cast stainless, if they look in AWS D16, it's a stainless steel structural welding code. There's a dissimilar joining table in the back, and they can look at wrought and cast alloys, and it'll give them recommendations. So if they're welding let's say a 308 stainless to a carbon steel, it'll give them a recommended filler, and it has the same thing for cast stainlesses as well, that to point them in a right direction, to get them at least matching strength and an appropriate alloy selection. Aluminum, in our Alcatech website, there's a dissimilar joining chart, very similar to the stainless one, where you could go in and say what alloys you're welding, cast, wrought, and what characteristics you want out of that weld. Do you want strength? Do you want high temperature strength? Do you want color matching for anodizing? And you choose what characteristics you want out of the weld, and it will point you to the right filler metal for that application. There's so many different choices depending on what the base metal are and the services that you're putting that part into.
Okay, and then how would somebody know if it's like the difference between cast material and wrought?
For the most part, is it a nice, clean product if you start to weld on it and you're getting a lot of, junk floating to the top of the weld pool, it's you're not going to notice in a slag process, but with TIG welding or MIG, if you start getting a lot of things floating to the top of the weld pool, it's a cast product. It's not as clean as a wrought process. When they may cast an ingot, but all the stuff that's from the steel making process is floating to the top of that ingot. It's getting scrapped out of the steel mill. You're in a cast product, you're going to get all those... Because you get
the sands and the oils and all that impurities.
Things mixing in, you're going to see porosity. It's not where in a wrought product you'd never see porosity. You might see like a delamination in a rolled product, something like that, but you're not going to see... You're going to see porosity. It's going to be a much dirtier product to begin with, and you could often tell with the surface finish of the material. Aluminum is very easy. It's typically an extrusion, and it's nice and smooth, and you'll see lines going along the long length of the product. Cast, it's going to be a very rough surface. Cast steels,
it's got like a textured look to it.
It's a textured look to it. Like you said, a lot of cast iron, it's going to look like it was made in a sand mold.
Yeah.
So, and stainless, you're gonna have that textured look to it. There's gonna be a chance of if you start grinding into it, you'll see little pores. They're not detrimental because you factor that in when you're designing the part, that you're gonna have so many pores in it, but you're gonna see them in there when you're working on a part or trying to repair it.
Gotcha. And then I would imagine ESAB has their consumables book that kind of recommends specific alloys for different types of metals.
Yeah, so
based on process.
Exactly. So, like I said, in our Alcatech welding guide, there's a dissimilar joining chart where you pick. I say dissimilar, but it could be the same materials. You pick your base material. If they're the same, great. If they're different, it has that as well, and it will recommend fillers. When it comes to more of like maintenance, repair, hard facing, we have our Studi welding guide, which will allow them to choose based on the hardness they want, or wear conditions. Is it tool engagement in rock? Is it tool engagement in sand? Is it metal on metal wear? And there'll be selections based off of the application that you're putting that hard facing in. And then for stainless, we have our Exciton welding guide for stainless, where it's an app where they can put in their base metals and it'll give them recommended filler metals, whether it's stainless to carbon steel, different families of stainless, a ferritic stainless to an austenitic stainless. That guide will work them through all the things that they need to make a decision about for that application and that
specific application.
There's not a an end-all, be-all filler metal for these different things. You need to know what you're working on and what service it's going into.
Yeah, I mean, they've got chapters written on every code book that's out there. I mean, there's sections, on joining base metals and making sure you have the appropriate filler metal for joining those.
Yeah, exactly.
Yeah. And I love the fact that you guys publish the literature, so people can find that stuff step by step, especially with hard facing. That seems to be a completely different animal. And like you said, whether it's like metal to earth, metal to metal, metal to rock, like all these different applications, it's not like a one size fits all. There's specific alloy or specific filler metals for these different types of applications because they all wear differently.
Exactly. And even if you think of on like one bucket. You have an excavator with a bucket on it. You're going to put one alloy on the teeth of the bucket. You're going to put a different alloy on the bottom of the bucket. You may put a particular pattern in. So you may put like cross hatching or like Xing on the side of the bucket to help with wear, to hold earth on to the bucket, so you getting...
So now it's earth on earth.
Earth on earth,
Yeah.
You're not wearing on your metal, but we would choose different alloys for the teeth of the bucket because you're going to be hitting stone. Or if this is a bucket down in Florida, it's very sandy soil, we're going to have different alloys for different different types of wear. Rather than impact wear, it's going to be abrasion wear.
Awesome. Well, Martin, thank you so much for your time. I'm going to let you get back to your show.
Yeah, thank you very much. It's great to talk to you.
Likewise.
Take care.
Thank you. All right, ladies and gentlemen, thank you so much for tuning in to the bonus episode with my friends over at ESAB. For more information on these products, solutions, and innovations, you can head on over to esabna.com. And be sure to give them a follow on Instagram at ESAB Welding Cutting. I hope you all have an awesome weekend. I'll see you right back here Monday morning for an all-new episode of the Arc Junkies podcast. Until then, stay safe out there and make every weld better than your last.